Hello and welcome. Today, I will be explaining how meteorologists use a Skew T diagram like the one shown here to understand atmospheric stability and thunderstorm potential. A Skew T diagram displays temperature, pressure, and moisture throughout the atmosphere. The vertical axis represents height or pressure levels, while the bottom axis shows temperature. The diagonal lines that slant from bottom left to top right are called isotherms. They show increasing temperatures toward the right. On the right-hand side, wind barbs display wind speed and direction at different altitudes. Now, let's focus on the colored areas. The red shaded region is called CAPE, which stands for Convective Available Potential Energy. CAPE represents the amount of energy available for rising air to form a thunderstorm. The greater the CAPE value, the stronger the potential updrafts and storm intensity. In simple terms, more CAPE means a greater chance for powerful storms to develop. Below that, you will see a small blue shaded area known as CIN, or Convective Inhibition. CIN acts like a lid on the atmosphere. It represents the energy needed for air to break free and start rising. When CIN is strong, it can prevent storms from forming. However, if the surface heats up enough to remove this lid, that stored CAPE energy can be released quickly, leading to rapid storm growth. The point where the red area ends higher up is marked EL, or the equilibrium level. This is where a rising air parcel becomes the same temperature as the surrounding air, and its upward motion stops. By studying these features, meteorologists can see whether the atmosphere is stable or unstable and how likely thunderstorms are to form. CAPE shows the fuel for storms, CIN shows the resistance, and the EL marks where clouds stop growing. Okay, thank you for watching this deep dive. Stay tuned for more weather insights and explanations, and don't forget to like and subscribe to the channel. Goodbye for now.